Okay, let's talk about explosions.
Sergeant right here.
Here we have a 5.5-inch howitzer from World War II. Now this is an artillery gun, and as we can see at the moment it's not firing. So what is its momentum? I can hear lots of you shouting, 0, because if it's not moving it has no velocity, because we know momentum is mass times velocity. So no velocity is 0 momentum, no matter what the mass of it is. Okay. Now, if we fire a shell from this, so we have a shell being fired in this direction. Okay. The gun itself, as you've just seen from the video, recoils backwards. Now, how does momentum apply to this? Because before it was fired, we have no momentum. After it's fired, we have some momentum. We have the shell or the bullet has momentum in this direction, and we have the gun which has momentum in this direction. Now, if I move this away and draw you a little one, okay, very basic drawings, which I'm sure you're getting used to by now. Now, when this is fired, our shell has momentum that direction. The gun itself recoils in this direction. Now, if we say this gun is 3 tons, so 3,000 kilograms, okay, the shell is only very small. It's 1 kilogram. The velocity of the shell is 30 meters per second, and this is an example. So 30 meters per second, we can work out the momentum of this is, again, write out the equation for momentum, mass times velocity. It would be 1 kilogram times 30. So momentum is 30 kilogram meters per second. Okay. Now, we know that in this direction we have a momentum, and in this direction we must have a momentum because it's moved. Well, because of the conservation of momentum, momentum before is equal to the momentum afterwards as long as no forces act. We can say that momentum before is 0. So if momentum is 0 overall, that hasn't changed. Before we fired this gun, momentum was 0. After we fired it, overall momentum is 0. But we know that velocity is speed with direction. Okay, that means that this momentum going in this direction is negative compared to this one. So let's have a look. 0, so we've already worked this out. This shell is being fired that way, so that's got a momentum of 30 kilogram meters per second. And we know that it must be equal to 0. So we know that we've got to take this one away from it. Now, we don't know the velocity that this has moved back by, but we do know its mass. So its mass, 3,000 times velocity. Now, it's a case of rearranging the equation. So if we've got something that's minus, if we take it over the other side, it becomes 3,000 V is equal to 30. And then if we, to get V on its own, divide both sides by 3,000. These ones cancel, so we're left with V is 30 over 3,000. Well, what's 30 divided by 3,000? Let's cancel out those noughts. We've got 3 over 300. And 3 over 300 would give us 0.01 meters per second. Okay, quite a complex thing to get your head around the fact that we've got momentum in this direction and momentum in this direction, which makes the total momentum 0. So if you've got any questions or any comments, please add them below. See you later.